Hi friends, in this video let us learn about how to solve the problems whenever we have a MOSFET with the source resistor and two sources. Here you see we have source resistor RS and we have two sources. One source is here and another source is here, right? For this source 1, we have source 2 and source resistor RS. This is RD, right? So what they have given threshold voltage is 2 volt, Kn is equal to 0.16 microampere per volt square. We have to design a circuit such that ID is equal to 0.5 milliampere. Current through R1 and R2 is 1/10 of the ID. What we have to find is R1, R2 and VDS, right? Okay, so I find VDS, right, and R1 and R2. So to find VDS, what is the formula for VDS? We know already how to solve this. VDD minus ID RD plus RS. This is what we have to find, right? Okay, so that thing we have to know, right? So here, fine. So RS and plus this minus 10. Oh, sorry, minus of minus, right? So if you apply KVL, it will be minus of minus, right? Why? Here you see we apply KVL at the output side, this side. So here what will happen? We start from here. This is VDD, total supply voltage. What is the drop? Subtract this ID RD. Then here D here S. So it will be VDS. So VDS. Sorry, the second source. So VDD minus RD. Next here subtract ID RS. Then you subtract this 10 volt. Okay, so if you subtract, this is a total voltage, subtract this drop and this drop, all the drop here, here, here. So if you subtract all these three drops from 10 volt, what you get is this drop. So that is what our VD is, right? So I have to find this. Okay, right. So if you want to find this, I know ID, VDD, I know RD, RS, everything I know. Right, so VDS is equal to VDD is 10 volt minus ID, right? ID is as per the problem 0.5 milliamps, right? So 0.5, okay, sorry, here VDD, that is what we have to mind it very carefully. So here you see this is with respect to, if it is simply 10 volt means it is with respect to ground. Supply voltage means it is with respect to ground 0 volt, but here ground is at minus 10. So what is the supply voltage? It is suppose VDD means here some VD minus V0, but here 0 is not at all at 0, it is at minus 10. So 10 minus minus 10 is 20 volt. That is very important. So originally VDD is 20 volt. With respect to ground only it is 10 volt. Please understand this. But here ground at minus 10, not at 0. So if it is with respect to 0, it is 10 volt. If it is with respect to minus 10, it is 20 volt. So what you have to put is here it is 20 volt. ID is 0.5. RD plus RS, we know RD is 20K, right? Plus RS is 4K, right? And plus 10 we have to add. If we simplify, VDS is equal to 8 volt. We found this. Let us keep this as it is. Next, what we have to find? We have to find R1 and R2 value. So we know ID is equal to Kn VGS minus VT square, right? ID is given in the problem 0.5 milliampere. Kn is, it is given in the problem, it is ID is 0.5, Kn is 0.16 microampere. 0.16 microampere per volt square. VGS I don't know. VGS minus VT 2 volts 2 squared. So if you simplify, what you get is VGS is equal to 3.77 volt. You may ask why I am finding VGS. You will understand why I am finding VGS soon. Okay. Next, what is the thing? We have to find R1 and R2 value as per the question. Right? From the problem, they are given that current through R1 and R2. This is the current flowing through this R1 and R2. Drain current, sorry, gate current is 0 because gate is insulated. So here all the current flowing through R1 will go to R2, which is 1 by 10th of ID. So current through R1 and R2 is 1 by 10th of ID as per the problem. I through R1 plus R2 is 1 by 10th of ID. ID is 0.5 milliampere. So ID by 10 is 0.05 milliampere. Okay. Right. Therefore, what is current through R1 and R2? That is given by current through R1 and R2 is 0.05. That you can equate to VD by RD. VD by R1 plus R. Yes or no? And I is nothing but V by R. So R1 plus R2 is equal to VD by 0.05. That is equal to 400 kilo. Okay. Now what we have to find, I know VGS. So VGS is given by VG minus V, right? So VG, how can I write VG from the diagram? You see VG is nothing but, here you see, VG is nothing but this voltage. This is VG up to here, right? Voltage across this R2 normally, but here ground is shifted to -10. So I am going to, this is voltage drop across R2 with ground shifted to -10. So what I am going to write, so I know R1 and R2 are in parallel series configuration. So total voltage drop across R2 is given by total voltage VDD. So already we know it is 20 volt. Why? Because ground is shifted to -10. So 20 into R2, I apply voltage divider rule, plus divided by total resistor R1 and R2, and plus I have to add that ground -10. Ground is not 0, ground is at -10, so I am adding -10. So then what I am going to do, R1 and R2 we know it is 400. So 20 into R2 divided by 400, right? And minus 10. What about VS? VS is given by, let us go and check. VS is given by, this is the source voltage. Here you see, this is voltage across from here to here. This is VS. So it is this RS, so ID into RS plus -10. So it is this -10, ground is -10. So what you have to do, VS is equal to ID into RS plus -10. Okay. So this will give VGS is equal to, this is VG, this is VS, VG minus S, that is equal to, okay, I subtract this. Okay, this we know, VGS, that we know already, we found 3.77, that is equal to R2 divided by 400. I have to add these two, VG minus VS. So this 10 and this 10 will be cancelled. So into 20 minus ID RS. ID value we know it is 0.5. RS we know it is 4 kilo ohm. So I substitute that value. 0.5 milliampere into 4K. Simply if you do that, you will get R2 is equal to 115.4 kilo ohm. We know R1 plus R2 is 400. So R1, this implies R1 is equal to 284.6 kilo ohm. So we found everything, right? So R1 found, we found, R2 we found. What is VDS value? We found already. VDS is equal to, VGS we found 3.77, VDS is 8 volt. So we assume this current ID, this formula is for saturation region, right? Okay. For saturation region, we know the condition to be fulfilled is VDS is greater than VGS minus VT. VDS is 8 volt, VGS 3.77, VT is 2 volt. So this implies 8 is greater than 1.77. So our assumption is right. The device is in, for these values, the device is in saturation mode. So this assumption is correct. I hope you understand this concept. If you have any doubt, please ask me. I will clarify. Thank you.